Hello, this video is to demonstrate and discuss a 1967 or 68 Valco made Gretsch Super Bass model G6157. What we're going to do in this video is what I've done for the past couple of videos. We're going to take a look at the amplifier schematic. Then we'll also take a look at the guts of the amp and see what it looks like on the inside. And finally, we will get a demonstration of what the tone is like after everything has been serviced fully. This amp I already know I'm going to need to do a little bit of servicing on. Still has the two-prong cord attached, which I will probably replace. Well, I'm sure I'll replace it with three-prong. The schematic shows that it does have a death cap, so I'll probably end up removing that one as well. Also, whenever I have plugged it in so far, I've gotten a little red plating on one of the output tubes. At least I think it was red plating, and it was definitely making a lot of noise. So I shut it off pretty quickly after I saw that, and we're going to open it up and see what the problem is. You can see here on the outside, first of all, one thing we recognize is this is one of the later Valcos, right before they went out of business in 1968. They tried to buy K around in 1967, and K was on its last legs, and I think what ended up happening is just the added burden dragged Valco down as well. So they were out of business by 68, and these are some of the last amps that they produced. When you see this style with the big faceplate like this, this is kind of Valco's last hurrah, the last couple years that they were in business. These are prone to corrosion. They're steel. They're all steel chassis, steel faceplate. None of the Valcos ever had very good plating to any of the chassis that I've ever seen. So that's one bad thing about old Valcos. They are prone to some corrosion for that reason. This is a pretty simple amp. It has three inputs. We can just see right off a volume, a tone control. We have a couple lights. One is an on-off light. The other's for the standby. Gretsch Super Bass logo is still visible in spite of all the obvious corrosion. We have a switch over here, which is actually labeled a tone selector. The tone is selectable from guitar to low bass to high bass, and that's pretty much just still legible there. We have a line switch for off in the middle position, on, and then the reverse on position for reverse polarity. We have a standby switch for standby and play modes on the back of the amp. And we'll flip it around quickly here. We can see right off the bat we're missing a couple of power tubes, and I will explain why that is in just a little bit. Looking in the back of the chassis, again, we see some of the same sort of corrosion. We've got a missing jack there, and then it looks like someone has added a jack as well beside it. Looks like we still have the original can caps in place. That could be one part of the noise problem. We will see. Another thing that we notice just looking at this is that we have a big power transformer, 6L6 output tubes, and those look like GEs to me just looking at them. There's one 12AX7 over on this side of the chassis. There's another one way over here on this side of the chassis. We have an output transformer here, and we have a second output transformer here. So we will delve into that just a little bit further here as we get into the schematic. Okay, here is the schematic for the 6157. You can see here on the output section there are 1, 2, 3, 4 6L6 tubes, which is what we saw in the chassis. It looked like we had space for 4 output tubes. We do indeed have separate separate output transformers for each of these pairs. And that would be why these 6L6s were pulled, because the previous owner probably wanted to only run this in 50 watts with just one of the output transformers, and it looks here as if there's no sort of safety dummy load that gets engaged when this is not being used. So the only way to save this transformer, and this is a strange design. I'm thinking, I haven't researched this model quite yet on the old catalogs, but I'm thinking this model must have come with, it must have been sold with 2 speaker cabinets. Otherwise, I don't know how they would justify selling a head that you absolutely had to plug in 2 speaker cabinets. Otherwise, you're going to burn up one of these transformers, these output transformers, if you run it without a load attached. So it's a good thing that those 6L6s are out, and someone's not trying to run just one speaker cabinet constantly with these tubes cooking, and this all of that wattage is having to be dissipated by this output transformer, because that would burn up pretty quickly if that were the case. And I will check the continuity of this and see if it wasn't already burned up. I have a suspicion that that might have happened. It makes sense that it would have. I'm sure not everyone would have caught on to the fact that there's 2 output transformers and that you would really want to remove some tubes. The fact that the tubes are removed is a good sign. Maybe somebody thought enough to remove them to try to save that, and so maybe it wasn't already burned. So we shall see when we open up the chassis later. But just looking around again, we see solid state rectifier. Of course, we did not see one inside the chassis, so that makes sense. Here we see our 3 inputs with 47K resistors coming into the first half of the 12AX7. Here on the power rail that comes into the 12AX7, we see it goes through a 100K resistor, and then there is a cap to ground, a 0.05 cap to ground from there, which I'm not quite sure what that's all about. That's a bit unusual. Then there's a 270K after that before it actually supplies power to that plate. So not exactly sure what's up with that. That's an unusual thing to see. And here another unusual thing is all of this tone network that's going on. We see it goes through a 47K, and there's a resistor here, 100K resistor that allows a bypass here, and then there's 0.01. So there's some kind of tone network going on here in conjunction with this tone knob. And then to further complicate things, you come out here and you have that range switch. That's what they're labeling it here. I think it was named selector, tone selector or something on the chassis there. But here we see the high bass, low bass, and guitar selections. Bunch of tone network things going on here. Here's your volume pot. So usually when you see something like that, like all of this tone network stuff, that can rob you of tone when you have too much stuff going on. I haven't plugged this amp in and had it working yet, so I'm not sure. This might be the best sounding thing of all time. Who knows? I guess we'll see a little bit later. But I usually, when I see something like this, I try to resist the urge to just jump to a modification that simplifies everything, because I don't like the homogenization of guitar equipment. I think not everything has to be a Fender. Not everything has to be a Marshall or a Vox or something familiar. Or, it doesn't have to have been used by Eric Clapton on some famous record in order to still be a cool amp. So I would like to be able to keep all of this stuff without having to bypass it or modify it in any way. So I'm going to wait until the end until we have everything repaired and buttoned up before I jump to conclusions and say that any or all of this stuff is unnecessary. So we're going to try to leave as much of this intact as we possibly can, and salvage the originality of this schematic the way that it was meant to be. Now we may not come back in here and put these 6L6s in without doing some sort of dummy load on this, because I don't think it's healthy to have these running. I think it's good that they're probably out. So we may just run this as a 50-watt amp and keep it as is in that regard. But we're going to try to restore it and just make it working as much as we can. Try to be respectful to the amp. You can see here, after all this tone network stuff, it comes through the volume, goes through another stage of gain before it gets to the phase inverter. And then it's on to the output from there, and the output tubes are cathode biased on each side. That's about it. That's pretty much what we're looking at schematically here. So let's open up the amp and see what it looks like on the inside. Okay, now that we have the chassis out of the cabinet, we can get a little better look at it. And one of the things that we've gotten here is an unexpected lesson in tube identification. The tubes appeared to be GEs from the back. They're both labeled RCA. One of these is a true RCA, and the other is an imposter RCA, or is actually just labeled RCA, but was made in fact by GE. The one on the left here is a true black plate RCA. You can usually tell RCA manufactured tubes from the little octagonal logo there. You can see the 6L6 GC in a little octagon on the glass. That one is a true RCA, and it is the black plate RCA. You can see the big micas that go all the way around the tube on the top and the bottom, holding everything together. Here on the right is a GE made RCA, and the reason you can tell it's a GE is usually GE tubes will have the tube designation. As you can see there is 6L6 GC USA, and they usually will say USA, and then below that you'll see a little pattern of dots on GE tubes. So this is a GE manufactured RCA labeled tube. What happened a lot of times, I believe, is, you know, if RCA was falling behind in production and they just were making a lot of equipment, or they had a lot of orders and they were falling a bit behind, in order to fill out some orders, a lot of times they would purchase from one another, and you'll see the reverse sometimes happen. You'll see GE labeled things that are in fact made by RCA. You'll see things that were made by Mullard that are labeled RCA. You'll see things that were made by Amperex labeled RCA. I think they did that, so they could round out their catalogs and so that they could satisfy their customers. I'm not sure if they would have put an additional layer of QC on top of this or not, but GE made good tubes. I have no reason to suspect this isn't a good tube. I think there's some other things going on in the amp causing one of these to red plate a little bit, or at least it was appearing to red plate. I'm not sure if it was truly or not, but we'll see about that. Probably what I'm going to do, I think these are most likely going to end up being pretty mismatched, so I'm going to drop in a new set of tubes for this amp and stash these away. Maybe I can use these in some kind of single-ended application later on their own. This black plate RCA in particular, these are pretty expensive tubes if you go to buy these, so that's a good tube I can at least hold on to, and this one would make a great little replacement for some single-ended single-ended 6L6 application, or if I can find another one that's closely matched, and I can match it with another tube and use it somewhere else. But I think what I'm going to do is put a new matched set of tubes in here and take that approach. Another thing that I noticed with this chassis out is a really alarming safety issue here. If you're reaching in the back of this amplifier, if something goes wrong and you're wanting to wiggle tubes, you know, and in desperation of getting your gig on, something's going wrong, and you reach back here to wiggle this little 12AX7, you know, hoping, praying to God that, you know, just by wiggling it, you're going to get everything going again. And if you go a little bit too far with it, look what you're going to do. Let me pull this 12AX7 out so you can see. Look what you're going to do. See those terminals in that little circle right behind that 12AX7? Well, that is the line, the AC line coming in on those little terminals right there. So if you accidentally overshoot this, or you're trying to get the tube back in, or you're trying to replace a tube in the middle of a show, and you have this amp still on, or even plugged in, and you reach back here, it looks like you're going to probably get quite a shock, and maybe even it might be the end of your touring days right there. So I'm not real happy about that. Probably before I send this on to a new owner, I'll at least tape that up pretty well from the inside and get alleviate that issue, because that's not something I'd be real comfortable with, to be honest. But yeah, that's those are the couple things that I see, and we'll take care of that, so the next owner at least has some chance, if he reaches back here, of not hitting that. One other thing I did notice with this chassis out is the date codes on the pots. Help us date the amp to late 1967. It may have been shipped out in 1968, but at least the pots were. They date to about the 31st to the 36th week of 1967, so that gives us a little better idea. And yeah, this is indeed right toward the end of Valco's days as a guitar and amp manufacturer. Let's flip this chassis over and see what the guts look like. Okay, here are the internal guts of the amp, and the first thing we'll notice is that it's fairly typical of Valco construction. At each side of the amp we have pieces of wood that's helping to support the chassis. The wood is always screwed in from the front and the back with screws, and then your mounting screws are screwed into the sides. And this is pretty typical of all the Valco amps I've ever had. Also typical of Valco construction are the terminal strips. Everything is mounted to terminal strips. There are several in this amp. 1, 2, 3, 4, 5, 6, 7, 8. There's about 10 or so of those. Here are our tube sockets for our output tubes. And we'll notice that, you know, this thing is pretty spread out. A lot of wires running from here to there. My suspicion is this thing could have been shrunk way down and probably still been a nice viable amp. Not sure why they made it so large. Maybe it was just a competitive thing where they thought the the purchaser would think, oh, you know, bigger's better. Don't know, but they probably could have shrunk this down by half, shortened a lot of these wires, and maybe even ended up with a slightly better amp. But as is, it's probably still going to be a pretty good one. We can see here some work has been done. I'm pretty sure this is a new, that's a new bias resistor. I think this is still the old, no, actually that would be a slightly newer, and this may have been done sometime even in the 70s or 80s, that Sprague. It looks like this and this were changed. I'm not sure why, but it looks like someone was attempting to bias this pair of output tubes, but they used the same value that the schematic calls for, so it's not as if they were trying to move this value up or down. Maybe the other one had drifted or had burnt, so that's something to consider as we move forward, that someone actually already has changed this, and looks like they've changed this as well. This should have looked like this one, because here's the pair of the 200 ohm and the I believe that's a 35 microfarad bypass cap for the output tubes. But there's our bias on this side, and this is the side that's not being used. There were no tubes in this. So this side was not being used at all. On the side that was being used, someone has replaced the bypass cap and the bias resistor on that side. So that might be something to keep in mind as we move forward. You'll also notice, as far as caps go, you'll notice several different brands. Standard, there's a Mallory right there. And then again, we have this brand, and I'm not sure what that brand is. That's also a Mallory. Excuse me. So we do have several different types. You see these a lot also in Valco amps. Several here as well. All the smaller values will be this type. So this is pretty typical of what you'll see in Valco construction overall. One of the things that have noticed, again, we know that someone has been in here, but it looks like they put a piece of tape here on the bottom of this switch to keep the terminals from accidentally shorting against the shielding paper inside the amp. I don't know if they actually had a problem with that or they were just trying to prevent it, but that's a pretty, it's just one little piece. So I think I'll replace this, and I might follow their example here, but just wrap it a little better, probably on top and bottom on this particular one, because again, from the other side, that's where you could reach in and get maybe even a bit of death from that. We notice a piece of tape here on this, so this switch has been replaced at some point. There's tape here, so they just spliced this in. I'll probably do a better job of this. I might even just decouple this wire and put some shrink tubing on that. Come over here. May do the same here, or just wrap that a lot better in some electrical tape to at least shield that a little better, so if it jostles around and does hit the chassis somewhere where we won't have a problem. Big bolt of lightning just struck outside, if you're wondering what that was. Sounded like. Buddy, that lightning scare you? Yeah, that scared me too. That sounded like someone was actually trying to break into the house. Crazy. Anyway, back to where we were. This is very typical of Valco construction. We're going to come in here and do those changes. We'll figure out why this amp appeared to have been red plating the tubes, and we'll have an update here soon. Okay, we now have the amp turned on, and it's plugged in, turned on, and I've made a couple changes before doing this. Now I have a pair of JJ power tubes, a new pair matched. Taped off the exposed terminals on the power switch, so that's no longer an issue. I've replaced the cable that was taped together. This one I've added more and better tape to, and taped it further down, so that's not in any danger of shorting anytime soon. Replace the coupling caps to the power tubes, as those were old, and probably it was best to do. Actually, here are the components that were replaced. These old standard caps like this, I've had a lot of kind of iffy ones in the past, and when I see these, I mean, they just pretty much are standard. They kind of live up to their name, and I've had a lot of bad luck with them in the past. So when I see them in critical positions like coupling caps, a lot of times I'll just go ahead and try to replace them. This is a 1 microfarad cap that was on the. I'll show you which position this was in. That was the one that was the bypass cap for the first gain stage. I have replaced that actually with a larger one. The second gain stage has a 35 microfarad 50 volt cap as the bypass, and I have put a 33 in this position to more closely match this one, and it should bring out a little bit more signal, a little bit more bass overall down the signal chain. So it'll be the amp will should just put out a little bit more all the way down the line. This I surmised early on wasn't original to this amp. I still believe that, as this is a 25 microfarad, and the position that it was in actually called for a 35 anyway. And what I've done is I've gone in and replaced that with this one here, which is a 50. And note, I'm not poking around in this thing with anything other than non-conductive material. This is a piece of wood. So what I want to show here, and here's the 33 microfarad that I noted replacing a moment ago. So really I've replaced just 1, 2, 3, 4 components, and then done the other little changes. And that's pretty much it. This amp is still making some noise, and I think I've discovered why. I'm going to flip the standby switch to the on position, and you'll see what kind of noise it's making. And right now it sounds kind of okay. I've got the volume all the way up, and you can hear the little bit of hum that's there, but here in a moment here we go, you should start to hear some popping and rustling. And when you hear this sort of thing, usually it means you have a bad capacitor or a bad resistor, and a lot of times it's somewhere near the input. And in this case, this little guy right here, I believe, is our culprit. I can pop this and the rustle will get worse. And these are notorious for being pretty microphonic, this style of cap. So, if I go over here, I can give you a demonstration. Listen to this. If I just tap on this, you can actually hear the sound coming out of the speaker. So I'm probably going to come back, and these three guys here, these are in the tone stack. They are, I believe, these three here. The 01, the 01, and the 02. I'm going to come in here and replace those with the newer poly style caps, and they'll be a lot less microphonic. So I'm going to at least replace those, and here comes the rustle. And you'll really be able to tell it in a second, because it'll only get worse and worse. And I'm pretty sure that rustle is coming from this component, which I'm definitely going to replace. And then these three here we will come back in and replace as well. And that's going to quieten this amp down considerably, I'm sure. So, and you can hear the rustle even getting worse. And if I give it long enough, that rustle will actually get to the point where it just takes over everything. So we're just going to pop it back to standby, and we'll come right back and show how much it's probably going to be quieted down after I replace those few components. Okay, here we are with everything buttoned back up, and we're going to take a listen to what we have here. For the purpose of this demo, I'm going to be using a 1988 American Standard Telecaster. Right now the volume is straight up and down. The tone is backed off a little bit from straight up. The selector for the tone is on low bass, which seems to be the only one that is really useful, if I'm honest. Guitar is very thin. Let me show you. Just really thin and anemic. The high bass, better. It still lacks the deep bass that as this. And if I'm honest, the tone kind of sounds like it's gone through a lot of shaping. I think all that tone network business that's going on in here is really doing a number on it, and I don't think it's frankly doing it many favors. So let's take a look at some schematics and see what we might be able to do to improve this one. Yeah, here's our original schematic again, and if you'll recall, we had all this whole tone shaping network along with the selector switch, which again seems fairly useless since only one of the selections is really has the seems to bring out the full tone of the amp. So to me, this whole switch, this whole section just seems pretty extraneous, and maybe even sucking some of the tone away from this thing. Now, if every single one of these selections, these three selections, were extremely useful and did something to the tone that was unique, I may just leave it all in there. Particularly if this amp was in great shape, if it didn't have all of the rust on the chassis, if it was in beautiful cosmetic condition, I probably would not change it and leave it up to the next owner to decide what he wanted to do with a pristine example. But as is, this thing could stand to be improved tonally, and we are going to do our best to see if we can't do just that. Now here is the original schematic. Again, we had a 500 picofarad cap that was removed from the input. I'm sure that was probably bleeding off a lot of highs to ground. It was actually removed from the grid to ground, and I'm sure that was bleeding off a lot of highs before they even got amplified. And this one seems to be pretty scooped out sounding. Really almost tinny highs and ice picky if you get past about halfway on the tone. So maybe that had something to do with it. Maybe they revised the schematic and put that in trying to fix that problem, but I think it's just rearranging deck chairs because of all this extraneous tone network that we have going on here. All of this stuff could probably go. This whole switch and all of this extra stuff can probably go. And the reason I say this is because one of the best sounding amps ever produced by Valco, the Thunderbolt, is much simpler, and it has a lot of the same attributes. Has two 6L6 output tubes, a couple 12AX7s, and in fact the Thunderbolt only uses 1/2 of the V1 12AX7, so it has a whole half of a 12AX7 that the amp doesn't even use, and it still produces an excellent tone. But what we're going to do is we are going to give this a modification just in the tone shaping network. You'll notice here this one has the 35 microfarad bypass cap on this first tube, which beefed it up. And if you'll recall, this one had the 1 microfarad, and we already changed that to a 35. So this first V1 tube already looks fairly similar. Now this has a 500 picofarad capacitor on the input grid. We are probably going to omit that and just leave all of this portion as is. Now we'll probably come in here. There is a 100 picofarad going to ground off of the plate. We will probably add this, but we may do a couple sound checks and see if it's necessary first. We will add this 0.05 cap, of course. The volume control comes first in this schematic, so we're going to have to rearrange the volume and tone, and because the tone comes first in this one. so we will have to switch places, and we will rewire that so that the volume comes first. And it looks like here there is a 300 picofarad bypass cap here, and then goes to our tone. Here's a 0.01 to ground, again probably bleeding off some highs. And this is pretty much what we're going to do. We're going to take this section here and just transplant it into this section of this amp. So we're going to pretty much remove everything here in this area, and we're going to replace it with these components here. So let me get this thing back open. Let me do these adjustments, and then we'll check back in and see what kind of changes to the tone this really made. Stay tuned. Okay, we're back with this amp now, and to say that we have made some changes might be a bit of an understatement. We've made some pretty drastic changes. As you can see, there's a lot less wires in this amplifier now. Reason being, we've removed all the wiring to the second set of tubes. We removed all of the associated resistors, all the biasing, the resistor and caps. We removed all the filament wiring. All of the filament wiring was wired through these tubes, all of it in series. The output transformer over here was, at that point, was just doing nothing but adding weight, so that's been removed. This helped reduce, removal of all this extraneous wiring helped just to reduce noise. All of the signal wires were routed through these wires as well in parallel. If you look at the schematic, all the wiring was going through these tubes to get over to these tubes. So instead, I've just run wires direct, which helped to reduce noise a little bit more as well. Went ahead and replaced the wires that were taped together with much better wiring. Taped up all of these switches to help with insulation, so nobody gets shocked on the other side. Removed all of the components. They were just on these rails. There was no need to have them there, so I just went ahead and removed them from the amp. It's just going to reduce a little bit of weight and keep everything a little bit cleaner. And plus, if somebody wanted to come in here and modify this amp later on, they'd have a lot more space to do it in. Removed two of the input jacks. You know, I don't know what the designers at Valco or you know, a few other manufacturers in the late 60s were smoking or drinking that week, but to have three inputs with the exact same you know, attenuation on each input is just ridiculous and crazy. I don't know what they were hoping to achieve. I don't know if they were hoping to you know, eke a few more dollars out for somebody not really being educated on what they were buying. But in any case, that there's no excuse for having three inputs coming over here. None of which were grounded inputs. So you know, when you unplugged the wire from them, they were just sitting here on the whole time. So that was just like big antennas of noise the entire time you're trying to play. So it doesn't make any sense from a tonal standpoint. It doesn't make any sense from a cost standpoint. Again, I don't know what they were smoking, but this has been pared down and wired as it should have been all along. Just a single direct wired resistor is now coming in. I've changed this to a 68K from the 47K. That should attenuate highs just a little bit because it needed it. It's a bit bright. But now we've got everything just pared down, just cleaned up. I've added 25K of negative feedback, which helped to clean up a little bit of harshness as well. Because again, you know, this is a souped up. This is essentially a souped up Supro Thunderbolt. There's a complete other additional stage of gain in there. And you know, it can get away from you if you're not careful. So the negative feedback helped a long way towards that. And just everything has been all the wires have been moved around, twisted. None of these were twisted before. The 6 volt filaments. So I've twisted what I could. Tried to get them out of the way of any signal wires, which I've run, as far away as I can from those. And just essentially cleaned everything up as much as possible, and simplified it. This has gone a long way toward making this a much better amp, and we will check out some of the tones of it. I've also removed all of the wires that were running to the switch that was no longer going to be used. There were several shielded wires all running through here to that switch. No, I mean, it's no wonder this thing was noisy. There were so many wires running at such a great length. And this is not a small chassis. This is probably nearly 2 feet wide, I would say. This might be 24 inches or so wide, this whole thing. I haven't measured it, but it's a pretty wide chassis. You've had some wires that were running from way over here all the way to the switch and back and then back and forth, and it just didn't make any sense to have all of that stuff in there, especially when it can be made a much better amplifier without all of it. So let's check out the tones now that we've removed some of that stuff, and I think you will agree that the amp is much better for the wear. Okay, here's the amp all plugged in. It's still out of the cabinet, as you can see, but at least this will give us an idea of what it's going to sound like. Using the same guitar as before, and we'll see what kind of tones we're getting. Still getting a lot of noise, mainly because I'm right beside the amp with a Telecaster. As I move away from the amp, that noise disappears. So the amp is not as noisy as it appears with me playing right beside it. So you have to take that with a bit of a grain of salt. This thing is very loud. I can say that's one of the biggest improvements of the changes. It just made it extremely loud as compared to before. I'm getting so many, because of the loudness, I'm getting so many rattles down here. There's things hung on the wall and everything else that are rattling, so you'll have to kind of take that with a bit of a grain of salt as well. But at the end of the day here, I mean, that wasn't even halfway on the volume, so you can already tell this thing has been turned into a monstrous beast, to say the least. But yeah, very cool amp, nice and bright. If I back off, good tone. Yep, very loud amp. Those changes, taking out half of it, has really brought out the beast in this thing. And again, basically what we have here in the 6157 Gretsch is a souped up Supro Thunderbird. So yeah, if you ever get a 6157, if it's pristine, I wouldn't recommend doing these sorts of changes. I mean, you're just kind of ruining something that's vintage and kind of all its own. But if you get one that's in this kind of shape and you want to improve it vastly, you know, you might think about some of the changes that we've made here, and it might serve you well. So hope you've enjoyed the video. Be sure to subscribe to my others.